Okay, so I want to do a couple short videos on using algebra tiles to help us understand polynomials and just getting comfortable with them, as well as doing questions without algebra tiles as well, so we're comfortable with that as well. Okay, so the first thing I want to look at is if you go into your booklet on page 186, and it has a skill builder. Okay, and this skill builder is talking about how we model integers. Okay, so I'm going to draw two squares. Okay, and the top one I'm going to leave blank, but the bottom one I'm going to shade in. And this one, anything that's shaded in, we'll call it negative, and anything that's empty we'll call positive. Okay, so the idea is that if we have one empty square and one full square, that would be like +1 -1, we have a 0. So this is called a zero pair. Okay, and that comes in handy later on, especially when it comes to subtraction. Okay, so we can model any integer in lots of different ways using zero pairs. Okay, so if we take a look at, let's do 3x minus 2. Okay, so we know that x's are long rectangular boxes. Okay, so right here, because I have 4 empty rectangles, that would be +4, but because I added one negative underneath, this is in my zero pair. This still says 3x. Okay, and then I'd have 2 negatives, so then I would have 1. Like, Miss Labiak, you are drawing too much stuff. That is true, but I'll show you what I mean. Okay, 1 zero pair, another zero pair, another zero pair, another zero pair. One negative by itself, and another negative by itself. Okay, so this says -2. This says 3x. Okay, this is a 0, this is a 0, this is a 0, and this is a 0. Okay, it doesn't influence our polynomial at all. Okay, so looking at this picture, you can cancel out the positives and the negatives and then read what you're left with. Okay, right on. So if we want to turn to page 187, that's the next page. So I'm going to go page 187. So just if you're following along, so you have an idea of where these kind of examples are coming from. Okay, we're talking about like and unlike terms, and it shows there, simplify this model by writing the polynomial that the remaining tiles represent. Okay, so the first one says example 1, and it has a big x squared, and then it has some rectangles, and then it has some small squares, and then it has another rectangle, and then it has some small squares. Okay, and these ones are filled in. Okay, so if we want to simplify this, okay, the first thing we could do, well, we can do it a few different ways. We can count everything up and then add it together. Okay, I like to group all of my like tiles first. Okay, so the first thing I like to do is put all the ones that are the same shape together. So I have only one of those, but then I have my long skinny ones. I have 3 of those. Okay, and then I have my small squares, and I have 4 of those. Okay, so now I've grouped the like tiles, and now I can remove my zero pairs. So I can basically cancel out a positive for every negative. Okay, so I have 1 positive here, so I'm going to cancel out that negative. I have 1 positive here, so I can cancel out that negative. Okay, and then what are we left with? Well, we're left with x squared plus x minus 2. Right on, just like that. Now, do you have to do the group like do you have to group the like terms with algebra tiles? No, you can quickly see that you can cancel them off by themselves in this very first step, and that's totally fine when you're using algebra tiles, okay? Let's take a look at one on page 189, okay? So turn the page. Okay, so page 189. Okay, now you have the skills what you need to do page 187 and 188. And on 189, it's just using, it's not using algebra tiles at all. Okay, so I'm going to take a look here and let's look at the example. Example 2b. Okay, so 2b says minus x squared plus 4x minus 5 plus 3x squared minus 4x plus 1. Okay, so this is a giant polynomial, and let's make things a lot simpler by grouping like terms. Okay, and so to do that, I am going to underline all the terms that are the same. Okay, so both of those have a degree 2. Okay, this one has a degree 1. There's another one with a degree 1. Okay, and this one is a constant, and there's another constant. Okay, so if we're not using algebra tiles, we don't have that picture, it is a really good idea to rearrange them and group like terms. Okay, so I'm going to put all of my highest degrees first. So I'm going to put the positive one first. It's just visually for me, I like that better. 3x squared minus x squared, and then I have plus 4x minus 4x minus 5 plus 1. And typically what I do as I'm doing this, I will cross them off to make sure that I did them, because it's really easy to, when you have really long polynomials, to forget something. Okay, so now we have grouped all of our like terms, and now we can simplify. Okay, so 3 minus 1 would be 2x squared. Remember our the term doesn't change, right? That stays the same. We're just changing the coefficient, right? And now plus 4x minus 4x, well, that's 0, okay? Okay, and then minus 5 plus 1, and that would be minus 4. Okay, so anything that has a coefficient of 0, we don't have to write that. So all we would have is 2x squared minus 4. Okay, so let's try one more. Take a look further down the page where it says check. Number 1D. Okay, maybe I'll keep that example so you can see it as well. Okay, so here we have 2x squared plus 6x plus 7 minus 2x squared plus 7x minus 11. The other thing you have to be careful is if you're copying down equations that you copy them down correctly. Okay, so now I'm going to find all my like terms. So I have 1x squared here and another x squared there. Then I have my x and my x, and then I have my constant and my constant. Okay, so now I'm going to group my like terms. Okay, so I have 2x squared minus 2x squared plus 6x plus 7x plus 7 minus 11. Now just double check to make sure that I wrote them all down. It also gives you a chance to make sure you copy them down correctly as well. Oh, I crossed off the wrong ones. Oh, that happens. Okay. Okay, and then now I can group my like terms, okay? So 2x squared minus 2x squared, well, that's going to be 0, okay? 6x plus 7x, that is going to be 13x. And 7 minus 11 is going to be minus 4. There we go. Right on. That is awesome. Okay, are there any others here that would be helpful? No, I think that's it. Off you go. You now have everything you need in order to do 5.2.